So warm greetings to listeners. This is Dr. K. MAKESH BABU, Assistant Professor in Computer Application, Bishop Weber College, Trichy. So I am going to present about robotics and its applications. In robotics and applications, I am going to present Unit 2, actuators and sensors and pneumatics of robots. So these are the two chapters available in this unit. So I start with actuators and sensors. So what do you mean actuators? Generally you know that actuator is a device that converts energy into physical motion, and most actuators produce rotary or linear motion. So like a system, it receives the input and produces some linear motion or a rotary motion. There are three major types of actuators, generally hydraulic, pneumatic and electric. Let us see one by one. So pneumatic actuators. So pneumatic actuators are powered by compressed gas and are used to create a mechanical movement. So with the compressed gas, air, like that, be the input for the system and produces a rotary action. So they are a popular choice of for many industries, as they can make very precise movements and are cost effective and powerful. So equipment that uses pneumatic actuators includes bus brakes, exercise machines, van motors, pressure sensors and etc. So pneumatic system tend to work faster than hydraulic and other actuators. So this is very important actuators used in robotic. So hydraulic actuators. Hydraulic actuators are used to produce linear movements. They consist of a fluid filled cylinder with a piston suspended at the center, and a spring is attached to one end to help with the return motion. So it is like a liquid, fluid, oil, etc. Using this will act as a input devices for the system and will create a rotary action. So these actuators are widely used in exercise equipment like steppers, as well as for clamping and welding, etc. So the third one is electric actuators. So generally the electrical energy is converted into a mechanical energy. So electrical actuators convert electrical energy into mechanical energy. This is done by powering a motor which triggers certain components to move. So example of electric actuators includes electric motors, stepper motors, jack screws, electric muscular simulators are used in robots. So more than that, three different actuators. These are some of the examples pictures of actuators. So pneumatic and hydraulic and the electric and the manual actuators. When we rotate the wheel like this, so in the two ends it will create a action. So more than that, these three different types of actuators. Electromechanical actuators. It is like a hybrid actuators. So electromechanical actuators are used to transform electric signals into either rotary or linear motions or both. These actuators are commonly found in healthcare equipment and manufacturing automations. The fifth one, hydraulic actuators. So this is with the electrical as well as the liquid. So hydraulic is used to give movement to hydraulic accumulator, which then provides the force necessary to power the industrial equipments. So like generating powers, solars, etc. These electro-hydraulic actuators are used. The next topic is sensor. Everyone knows that it will act as a input devices for the robotics that fetches the data from various environment and stored in a computer system. So these sensors are nowadays very important to receive inputs in various angles, various measurement, etc. Sensors are the devices that can detect and respond to changes in the environment. These changes can be in form of light, temperature, motion, moisture, or any other physical property. The sensor converts these physical changes into signal that can be measured. Generally, they are used for collecting, analyzing, and processing data about the specific environment so that it can be monitored, measured, and controlled more easily and efficiently. So before analyzing the data, we have to fetch the data and store it into the computer system, any of the storage devices. Then it is summarized, then it is analyzed, then it will go for processing. So after processing the data only, we can able to make decision accurately. For that purpose, we have to store the data very accurately. So using different types of sensors, we can measure different types of data, and we can read different types of data and store it into the computer system. We are having different types of sensors that can be used in the robotic system. Generally, the sensor acts as a input device that fetches the data, and then it transmits to the processor for processing. After processing the data, the actuator receives the input from the processing unit, and it will work according to that. That will create a different movements or rotary actions. So generally transducers are there. It converts the signal from one physical form to the another physical form. It is also called energy converter. Generally sensor will act as an input device that fetches the input and process, and that will be act as the input for the actuator. So actuator again converts the input devices into different output. For example, microphone converts sound to electrical signal. The main types of sensors are active sensors, passive sensor, analog sensor, and digital sensor. So generally analog sensor sense the analog signals only. So digital sensor sense the digital signal. Active sensors external power source to function. So that fetch the data from the external device and fetch the data and stored into the robotic system. So passive sensor generally generate their own power source to function. So that will have the input devices, sensors, and other storage and power supplies in the robotic unit itself. So generally we can call it a passive sensors. So these are the main types of sensors. So again, the sensor, it is divided into two different state. One is internal sensor and another one is external sensor. So generally internal sensors measure the robot at internal state that analyze the robotic itself, right? How the locations, the charge is available in the robotics or not, how far it can transmit. So like that, it analyzes completely about the robotic system. So generally internal sensors such as its position sensor, velocity sensor, acceleration sensor, so motor, torque sensor, etc. obtain the information about the robotic itself. So external sensor, also known as ambient sensor, it is a type of sensor that is placed in the environment in a fixed position and does not require a direct connect with the user. That is, there is no direct connection with the system. So external sensors such as cameras, range sensor, etc. that using the Wi-Fi or internet connections. So those input, the data are fetched using by the sensors and transmit to the robotic system. There we have a storage devices to store the received data. So these are the two different important sensors available with the robotic. One is internal sensor that sense about the robots itself, and external sensor sense the data from the external environment. See some different types of sensors. So that can be used in generating different types of projects to give different types of applications. So this for color sensors, gas sensors, LDR, temperature sensor, alcoholic sensor, smoke sensor. You can see rain sensor is also available here. Then water flow sensor, IR receiver, ultrasonic sensor, right? So gyroscope sensor, humidity sensor, touch sensor, so IR sensor, so reflective and transmissive type. So one is for receiving and transmitting right through the input devices. So these are the different types of sensors available in robotics for fetching the data accurately. So let us see different sensors that will be added into the robotic system. So that will measure measure completely about the robot itself as well as the environment work area. So tachometer, it is a meter used to measure the revolutions per minute of a moving object. So tachometer is a type of sensor that typically used in motors and other machines and are widely found in automotive and aviation industries. So these sensors are used to fetch the data. So how many times that revolution occurs. They are also known as revolution counters. This sensor also is also known as revolution counters. So next one, torque sensor. Torque sensor are devices for measuring and recording the torque on rotating systems such as gearboxes, crankshaft, rotors, and engines. So generally these sensors are used and placed in a joint area for rotating action, and so how far it is rotated, the degree, it will also measure the degree of rotations that will fetch degree data and stored into the storage devices. So these are often used in industrial and technical applications to track the effectiveness of various systems, including machines, motors, and engine. Right? That mainly the ABS systems are used in car and other locomotive and automatic machines. So there we will have different types of rotating shafts. There they will fix this type of sensor and they measures right how far the shaft is working, how far it rotating, and how far uh, how much speed it is rotating. All these type of data are fetched by these sensors and given to the system. A strain gauge converts a torque into an electrical signal. The sensor is bonded to rotating shaft that deforms when a torque is applied. So this figures shows here the torque sensor is fixed in between the robotic and the end effector, and also a gripper is also there in the end effector. So end effector is the main part that touches the end of the right and of the objects. So that is that this torque sensor is placed between the robotic arm and the end effector. Here, this sensor sense that how much this end effectors rotates, right, to fetch the data. So these are the different types of shaft. So that I want to show to you, because you may, after seeing these images only, you may able to know that what it means shaft and where we can keep the sensors to measure these types of data. Here you can see that input shaft here is a, so shaft, this is the rotating area that rotates the total gear. So here they will fix the sensor and they will receive the data how much this shaft is rotating, how much shaft is working properly, so they can continuously monitor the shaft for their accuracy. So these are the different types of softs available in different machines to produce different types of outputs. So next one is a proximity sensor. Generally, these sensors are used in real time. There is no direct connections between the robotic and the sensor device. This sensor device is not directly connect with the objects. We can place the sensors near the object to fetch the data. This is a device that detects the presence or movement of a nearby object without physical connect, without having a direct connect with the particular object. We can sense, right, how these objects are moving from one place to another place. This can be fetched through by this proximity sensor. Sensors are a part of everyday life at home and work. A sensor is a device that can see, feel, hear, smell, and even taste. Right? So that will hear, smell, and even taste. Taste means based on the power, the salt like sugar or etc. So that will measures the quality or the density of the particular data. Through that sense and gives the data to the robotic system. So next one is the types of, these are the different types of proximity sensors. So I already explained about the proximity sensor. So it won't have a direct connection with the objects, that uh, reads the movement of each and every objects and stored into the computer system. So like that we are having capacitive proximity sensor, inductive, magnetic, optical, and ultrasonics. These different types of proximity sensor is based on the different type of the the mechanisms are used, or the material used to fetch the data. So here ultrasonic rays, by using through the ultrasonic rays we can fetch the data. Through the capacity, the power supply, we can fetch the data. Through the optical proximity, through the power of the light source, we can fetch the data. So inductive, so through the power. So these are the different types of proximity sensors that fetch the data, right, without the connections with the particular object. Next, proximity sensors comparisons. You just see inductive. Our sensing range is 4 to 40 mm. So applications, any close range of detection of ferrous material. So target materials iron, steel, aluminum, copper, and etc. So then capacitive torque proximity sensors. So that ranges from 3 to 60 mm. Detect non-ferrous material, a liquid, wood, granulates, plastic, glass. So these are the different materials that can be able to sense by the particular proximity sensors. So this one is the photoelectric sensor. So long range, small or large target detection, silicon, plastic, paper, metals, etc. So if any if this sensor found like this silicon or plastical materials, so that identify and gives inputs to the system. So finally you will have ultrasonic. So this one is also you able to measure from 30 mm to 3 mm. So that fetches inputs data like foam, glass, liquid, powder, cell phone, etc. Next one is a very simple and easy to handle is a distance sensor. So distance sensor generally used to measure the distance between the object and the sensor. So if you fix the sensor in a robotic system, so we can identify the distance between the object and the particular robotic system. So through this sensor, the robot can easily identify the locations or the distance between the object and the robotic systems. So there are several types of distance sensors available, including ultrasonic, laser, infrared, and optical sensors. So ultrasonic generally through a beam of light that will measure that will place on the particular object, that will measure the length of the beam of light from the robotic system and the object, like that laser and infrared also like that. So you all are belong to the same light sensors that will generate a lights and produces on the particular object, and it will measure the distance between the object and the robotic. Then slip sensor. This is very much important also. This is connected with the end effector, which I already told in the previous slide. There you can see that the sensor system implemented in the gripper is used for detecting of slipping through of object during the gripping process. So this is mainly attached with the gripper, that is end effector, because the end effector is only going to interact with the particular objects. So this can be attached with the end effector. If the end effector catches any objects, that gripper will sense that whether the particular object is strongly attached with the end effector or not. If any grips is there, the end effector will lose the particular object. So this measurement is also very, very important in the machineries, because they are handling your hard arms, irons, the electrical and heat materials with the grip with the end effectors. So that should be carefully handled. So this type of gripper is very, very important in handling the different types of materials. So frequency selective evaluation method is used to detect the slipping of an object to be grasped. So different algorithms are there. This is one of the method evaluation technique that is used to detect the slipping of an object to be grasped. Well, let us see this diagram. This one is the end effector. So again you will have the light that detects the objects, and here you will have a grip. You will have a gripper, and that gripper is attached with the system. So this gripper sense the total end effector whether it is attached with the object or not. So if it is trying, the particular object is trying to slip from the end effector, that immediately gives a intimations to the particular robotic system, so that the end effector can manage the particular object. So next topic. So up to this we had studied about the sensor. This sensor is very, very important. Basically in a system, the system consists of input device, process and output device. It is a interrelated components to achieve some task. So like that, a robotic system is also a interrelated components, that is input, process and output to achieve some task. So sorry. So we need a sensor to sense the data and act as input device and receives the input and stored into the robotic system for further processing. So input device is much needed. We need a storage devices as well as that produces the output. So sensor is very much important in a robotic system. So the next topic we are entering into the robotic system is the pneumatics of a robot. So what do you mean the pneumatics? It is related with the joint angles. It is related with the joint angles. Here you can see that. So here some of the different types of joints are there. So why these joints are used? So when you make a action, when you make a rotations of a particular robotic system, so we have to create such a actions. Just see in your hand, you will have a joint angle here. So then only we can create a motion, we can create a rotations like this. So pneumatics of a robot relate the joint angles of a robot to the coordinating frames of its links. So pneumatic is the study of relationship between the robot's joint coordinates and its spatial layout. So how far the end effector reaches the object, so that is defined with the spatial layout, and the turn, the rotations of angles of a particular end effector or a different types of joints. So this pneumatic of a robot explains about you how much different types of angles are there, right, to create such rotations, right, in the robotic system. So robotic pneumatics can be classified into two types. One is a direct and a inverse pneumatics. So next, forward pneumatics and a inverse pneumatics. These are the two different types of pneumatics available. So forward pneumatics use the pneumatic equation of a robot to compute the position of end effector from specified values for the joint parameters. So here you can see that, sorry, here you can see that there is an end effector is there and the Cartesian space available. So how far it rotates and how far the end effector occupied reaches the particular objects. So that will be explained through this position. So here just see once again, forward pneumatics uses the pneumatic equations of a robot to compute the position of end effector from specified values for the joint parameters. How far this part will be bent and how far this part will be bent and reaches the particular object. So the end effector only create an action with the another object, creates a interaction with the another object. So that end part is this evaluation is made with the end part and with the particular object interactions, right. This is what we can call it as a forward pneumatics. The second one is inverse pneumatics, the reverse process that computes the joint parameters that achieve a specific location of the end effector known as inverse parameters. So how long it reaches the particular object to interact, right? The end effector calculates the total distance or total number of bend, right? Total number of joints needed to reaches the particular object. So like that, again they have to be settled in a same question. So how many same joint angles are required, how many rotations are required to settle in the same places. So then we can call it say inverse pneumatics, right. So that achieve the specific portion of the end effector known as inverse pneumatics. So we can call this is a Cartesian space to joint space. Generally we can call it a forward pneumatics, and joint space to Cartesian space generally we can call it a inverse pneumatics. So joints, robotic joints are much needed that create a axis, that create a rotation, so that create a movements from one angle to another angle. So joint is also very important in robotic system, which are sometimes known as axes, are the movable parts of a robot that cause relative motion between the adjacent links. A joint is a part of the body where two or more bones meet to allow movements. So these are the different types of joints that is implemented in the robotic system. So one is collinear joint, input link and output link. So this will rotate in x and y axis, right. So that will create a movement of the x and y axis, right. It will create a T like movements. Second one is the orthogonal joint. So it's already in T-leg joints that creates a complete rotations. So the next one is a rotational joint, right? So that will create a rotations from 180 degree to 0 degree. So this is a rotational joint, and the twisting joint. This is not a rotation. It will create a twist along from a center point of a joint, right? So this is also very important designing or cutting of plates, etc., like that. So then revolving joint, so that will revolve in any direction, that will create a 360-degree of rotations in all the four quadrants. So we can call it a revolving joint. So these are the different types of joints available in a robotic system to create such a motions and to reach the objects using the end effectors. So linear joint, we can call, there are different types of joints are there. The first one is linear joint. The For each and every joint, they named using some different name letters. The linear joint is typically named as type L joint. That will create a L joint. It will move like a L position. In the linear joint, the relative motion featured by the adjacent links is meant to be parallel. This means that the input and output links are sliding in a linear motion, that is in a ordered line. This kind of linear motion can be achieved in several ways, including the use of telescoping mechanism and piston. So next one is orthogonal joints. We can call it's a O joint. They features a relative movement taken by the input link and output link. This kind of motion involved in the orthogonal joints is a transactional sliding motion, right? To slide from left to right. So then next one is rotational joints. It is named as R joints. These movements are carried out with the axis of rotational per second, the axis of input and output links. These rotational joints are very much important in the robotic system, and it is named as a R joints. So next one is the twisting joints. It is typically a T joints. This type of T joint features rotary motion that will result in some degree of rotation when in use. The movement in these joints is related to the axis of rotation that is perpendicular to O, the axis of the input and output links. Revolving joints, we can call it a V joint. So this is create a revolution of a particular end effector in a particular position, designed to be parallel to the axis of rotations of the joint. On the other hand, the axis of the output link is designed to be perpendicular to the axis of rotation of the joint. So these are the various types of joints that is included in a robotic system to create a rotation, create a movement of a particular end effector in all the directions. The next topic is frames. The world frame is the default frame of the robot and cannot be changed by the user. So generally the frame is the place occupied by a robotic system, as well as the moment the end effector reaches the particular object where it interacts with the particular object. So the total space is generally occupied and calculated as a frame. Frames in a robotic define a coordinate system that the robot uses to know where it is and where to go. That tells the total space, the movement of a particular robot, the movement of a particular that end effector. So all are measured right in a particular axis. The x-axis, y-axis and z-axis in 3-dimensional. The frame consists of the main 6 components, and x, y, z axis and a rotation about each of these axes. Not only the axis like x, y, z, also it rotates from a particular x, y and z axis is also measured. So homogeneous transformation matrices. So generally we know that it is a related data, a related item that is transferred from one place to another place. So this transformation matrices combine both the rotation matrix and the displacement vector into a single matrix that calculates both the matrix to give such a result. So finally, we entered into a topic named DH matrix. So these are the very important matrix. It's driven by Denavit and Hartenberg. So it includes more parameters used in robotics to describe the robotic properties like axis, rotations, and arm length. A commonly used conventions for selecting frames of reference in robotic applications is the Denavit and Hartenberg DH conventions, which are introduced by Jacques Denavit and Richard S. Hartenberg. So these are the two persons who introduced and invented these types of different types of parameters that are used in robotics to maintain the rotations. So in this convention, coordinate frames are attached to the joints between two links such that one transformation is associated with the joint Z and the second is associated with the joint link X. So differential pneumatics. So this tells the joint velocities of a robotic system. Also it tells the mobile robotic behaves. What the mobile robotic behaves, how far it is used and how far it works to gives the clear output of the input data. So differential pneumatics is presented which gives the relationship between the joint velocities and corresponding end effector linear and angular velocity. So mobile robot pneumatics is the dynamic model of how a mobile robot behaves. So differential wheeled robot is a mobile robot whose movement is based on two separately driven wheels placed on either side of the robot body, right? So wheeled mobile robots are dynamic systems wherein a torque needs to apply to wheels to obtain a desired movement of a robot in a different platforms. This diagram shows you, right, a wheeled mobile robotic system. It has a wheel. It also a revolution and rotational system to move either side to reach us the particular task. So this is what a